Hello, Math 20-1. We have saved the best till last. I put this slide, and I believe it's on your PowerPoint, not because there are there's some things that you have to write down. In this case, all I wanted you to see was that this is what teachers see. And I wanted you to look at this because this is the list of learner outcomes and achievement indicators. So this is what we're doing in this particular problem. We're determining any restrictions on values of the variable in a radical equation. So notice that when we think of teaching these things, some of these things are just for mere mortals, and some of these are standard of excellence just for supermen and women in terms of their math abilities. And they don't necessarily really hard, they're just deeper understandings that may or may not take away from completing the answer to the question, right? So this is the list of learner outcomes that's going to be happening here, all right? As we continue on, and you can read through those, as you continue on, what are we doing? We are solving radical equations. So, if we're going to solve a radical equation, the first thing we should probably do is understand what they are. And clearly a radical equation is an equation that has a radical in it. So this is a radical equation, and that's a cube root radical equation, and this is a radical equation. And notice that some of these have one radical, and this one has two. We're going to use some special tools in order to solve these things. And because we're using special tools, with great power comes great responsibility. And therefore, we need to be careful after and check things out. The power rule, we will raise equal quantities to the same power, and the results will have two equal quantities. But this isn't always true, and you need to be aware of that. So you might say, well, yeah, sure it is. Y equals x, that's always true. And if you think of the answers that work there, you would say, well, if y always equals x, then your answers for this equation would be, okay, well, 3 would be 3, and minus 3 would be, minus 4 would give you minus 4, and if x was minus 5, then you'd have to have minus, because x always equals y. But if you think of the list of possibilities that work in this situation, they are not the same, because I could put minus 2, and it wouldn't matter whether I put plus 2 for y, or I could also have minus 2 for y. And notice that's not the same as what we had before. Or if we keep the same numbers we had, that first example of x, if I put down 3, you would say, well, the only thing you can have over there to make this equation true would be 3. But that's not true, because I could also put down minus 3. So there are two possible answers for y, given that you have x squared equals y squared. Because 3 squared gives you 9, and both 3 and minus 3 squared for y give you 9. So it's a different situation. They're not equivalent because they don't have the same answers. Whoa. So we need to be aware of that as we solve equations, right? There's something else that's really important. There's something called extraneous roots. An extraneous root is a number obtained when you solve an equation that doesn't satisfy the initial one. Okay? So if you start with a simple equation, like x equals 3. If you square both sides, well, you got the same equation, x squared equals 9. But that's not true, because if x squared equals 9, you got two answers, 3 and minus 3. And minus 3 is actually the extraneous root, because that came as a result of you squaring. And squaring does weird things. The only answer from the beginning was 3. So we can't have minus 3. That's extraneous. Now, if you consider in this case, what if we did something else? What if we had something else? What if we started with something like this? X plus 3 is equal to 4. Now, everybody knows, for this example, everybody knows, well, I can tell you that if I took the 3 to the other side, I know the only thing that x could be is 1. That's what you think. But watch what happens when you square. If you square both sides, right? If you square both sides, we get x plus 3 squared is equal to 16. That means that x squared plus 6x plus 9 is equal to 16. We now have a quadratic. I remember quadratics. X squared plus 6x minus, the 16 comes over, becomes minus 7 equals 0. So now we factor it, and we get x plus 7 times x minus 1 equals 0. So now I have two answers, x equals minus 7 and x equals 1. Wait a second. The original question only had an answer of 1. How could there possibly be two answers now when the original question only had 1? As a result of squaring, we've created an extraneous root of minus 7. And you can ponder, where did that come from and why does squaring create that? You think about that. Tell me about it, okay? But it's a good question to ask. Why? So now we start with, what about equations with one radical? So the skills that you have to follow through to solve that are, well, I'm going to isolate the radical on one side of the equation, it already is, and then I'll apply the power rule and square it. I do, and I get x plus 3 is 16. Nice. I now know that x equals 13. That's a good answer. I wonder if it actually works. So you verify by substitution. You have to do this. You have to. It's not an option. I know in the back of the book or in the assignments it always asks. That's part of what you do. As soon as you have to square something, you have to do that. You verify with the radicand restriction, and right? What's my restriction say? X plus 3 has got to be greater than 0. My restriction says I've got to be x is greater than or equal to minus 3. My answer says it works, and it definitely is greater than minus 3. So we are happy. This question works. Big check mark. Yes, everything is good because it's been verified by substitution and the restriction is not violated. Okay. In the next question, again, we have one radical. The radical has been isolated. So what do? We square it. Be careful. You have a binomial squared. Don't think that's 16 minus x squared or 16 plus x squared. It's x plus 2. The radical blew up. And 4 minus x squared is 16 minus 8x plus x squared. I take it all to one side. It's quadratic. I factor it. Right? And I get x minus 7, x minus 2. This is good. I now know my answers are x equals 7. Really? Are you sure? Are they both true? That power rule might have mucked us up. So we're going to verify it two ways. Look at the restriction and check it by verifying substitution. When I check it by substitution, I go x equals 7. That doesn't work. 7 plus 2 square root 9, 3 doesn't equal minus 3. Doesn't work. Done. Check the other answer by substitution. Whoopsie. Check the other answer by substitution, and it works. But we should also check it by verifying it by our restrictions, right? So if I verify by restrictions, I've got x plus 2. X plus 2 has got to be greater than or equal to 0. So that means that x has got to be greater than or equal to minus 2. Now, in the question here, right, so there's my restriction. Yay, x equals 2 works. But notice that x equals 7 worked in terms of the restriction. So why would just verifying the radicand with the restriction not be sufficient? Because x equals 7, according to the restriction on the variable, actually it works with the restriction on the variable, but it doesn't actually work when you substitute. So substitution, by verifying by substitution, is essential. You have to verify by substitution. You can't just look at the restriction and say, oh, they're both bigger than minus 2, I should be fine. No, as you can see, that one doesn't work, okay? Now it's your turn. Go, fly. Follow the rules that were discussed in the first example, one radical. Okay, now you've come back, you've done it, okay, 30 minus 3x, I isolate, I square, I factor, and I get answers again of 7 and minus 2. I check by substitution, always, always, always. That one works. X equals minus 2 does not, therefore the solution is x equals 7. Can you just verify by the radicand restriction? No, you can't just do that. It doesn't hurt to look at it, but once again, if you look at the radicand restriction, 30 minus 3x must be greater than or equal to 0. So that means that 3x must be less than or equal to 30. If I divide both sides by 3, I get x is less than or equal to 10. Notice that both of those answers are less than or equal to 10, but only one of them works. And clearly, the only one that works is, whoopsie, is the 7. Yay! That one works. Okay? Carrying on. Are there anything tougher than this? Oh, there is. There are questions that have two radicals. So here's the procedure for solving two radicals. A recipe, you might say. Again, as soon as we have squaring, you're going to have to check. Squaring can create extraneous roots. Okay, so 4 root x. We have to isolate a radical on one side. Well, this is a nice one because they're both isolated. So we square both sides. Oh, that's beautiful. We square both sides. It blows up the radical. I get 16x and x plus 60. I solve it. 15x equals 60, x equals 4. And you might be happy with that answer, but does it actually work? Let's see. I verify by substitution. I get x equals 4. But you know what? You need to be careful. Does it actually satisfy the restriction on the radicand? Well, let's see. X has got to, when you plug in there, do you get the square root of a negative? X has got to be greater than or equal to, in this case, greater than or equal to 0 is the restriction overall. And therefore, it does actually work. Okay? When we consider, oh boy, we're working our way up the ladder. So the next example has two radicals, but they're both on the same side. Remember, it said I need to isolate one of them. It doesn't really matter which one, but you got to get one of them by itself. So you square it. You square both sides. Be careful. This is a binomial. Do it and see what you think. But when you square it, the one radical blows up. This does not. Right? You need to square the first term, square the last term, multiply the two together and double it, and you get a middle term. A binomial squared doesn't just give you two terms. Okay? Right? You have to FOIL it completely out. If you do, that's what you get. Oh man. So I blew up one radical, but I still have one left. I need to play the game again. Isolate this radical here and get everything to one side, except you can leave the 4. Now square it again. Aha! Now we need to go to the next page because we're running out of room. Okay, so we go over here and we get x squared minus 20x plus 196 equals 16x plus 7. We again are going to take it all to one side because it's quadratic. I factor it, and you can pause at any time. You don't have to be racing through with Mr. K. Right? So we get x minus 42, so that means x equals 42 or x equals 2. And you can't trust this squaring stuff, so you check both of those answers. Maybe they both work, maybe none of them work. If you check x equals 42, yay, it works. If you check x equals 2, wow. Don't assume that always one won't work, because many times they might both work. Okay? In this case, oops. In this case, they didn't, I don't know if we said to verify, but in this case, we still should probably verify our radicand restriction. All right, your turn. Oh, two radicals. Go forward and see what you can do with this one, then come back and watch. Okay? So, if you followed the procedure we developed from last time, we isolate one radical. Really doesn't matter which one. But I isolate that one. I square both sides. Watch the fact that this is a binomial. 2 squared. Root x plus 2 squared is just x plus 2. Multiply the two terms together and double it, and you get 4 root x plus 2. You now have another radical, but at least you only have one. You need to isolate this radical. Isolate, isolate. Get that by itself. Okay? So you take everything else to the other side, and when you do, you get x minus 3 equals 4 root x plus 2. Now you square it again. You get x minus 3 squared. which gives us x squared minus 6x plus 9, and 16 times x plus 2. We're running out of room. So we now, again, we would take it all to one side. We get a quadratic, and we factor it. And we get two answers of x equals 23 and x equals minus 1. You can't trust that, so you check them both. 23 works. X equals minus 1 does not. And therefore, the only answer we have is x equals 23. And you could, I didn't in the last one, but you could check out the two restrictions. And from the very beginning, you had two restrictions. X had to be greater than or equal to minus 3 halves. But on the other radical, x had to be greater than or equal to minus 2. So, in this case, the one that satisfies both of them is this. Now, you'll notice both of our answers are more than minus 3 over 2, but clearly minus 1 didn't work out, right? So, restrictions are important, but they don't always help us very much in terms of the answer, okay? You'll notice that you have an assignment, but your notes are actually, or sorry, your assignment is not out of your workbook, it's actually right on your handout. So please follow these, and also please notice that, I know it's kind of on its side on PowerPoint, but the answers are right below the first few questions. So the answers are built into the actual assignment page. I've cut and pasted them in there, okay? Those aren't questions, those are actually answers. Take care. Talk to you soon.